Saxon, Course 3, Lesson 2, Operations of Arithmetic. The fundamental operations of arithmetic are addition, subtraction, multiplication, and division. Right on the screen, we have the terminology used when solving different type of word problems. We will see how the problems are written out and the words used to create a problem to actually solve it. Let's take a look at an example. Example 1. What is the quotient when the product of 3 and 6 is divided by the sum of 3 and 6? When looking at this equation, let's go ahead and underline the words that we need to use when solving this equation. What is the quotient? Underline quotient. When the product, underline product, is divided by and the sum. Those 4 words help us create a problem to solve. Alright, now let's actually create the problem. The first word we underlined was quotient. And if you look at the terminology, you see that quotient actually is a division problem. So let's go ahead and put a division sign down here, because we know that we're going to be dividing. Now let's figure out what's going to be on the right side of the equation. It says when the product, of course, when you look at the terminology, product is the answer of a multiplication problem. So we're going to have multiplication here. We'll put this in parentheses to separate the left side and the right side. The product of what 2 numbers? 3 and 6. All right, now let's look at the right side. If you notice, it says the product of 3 and 6 divide by. We already put the division sign there because we knew the quotient was the answer division sign. So that divide by, we just leave alone. Then we have the sum. What does the sum mean? Addition. And once again, I'm putting this in parentheses to separate from the right and the left. The sum of 3 and 6. So we use the underline words to create our problem. And now we just solve it. What is 3 times 6? 18. Divide by 3 plus 6, which is 9. 18 divided by 9 is 2. In example 2, this is just good review. It says simplify and check. So we're just going to solve these 2 problems and then check our answer. Remember, when checking our answer, we do opposite of what's showing. So it's 706 minus 327. After we solve it to check it, we're going to end up adding. Let's review. 706 minus 327. And of course, remember all the rules when solving these equations. You have to borrow, then subtract. 16 minus 7 is 9. 9 minus 2 is 7. 6 minus 3 is 3. So the answer is 379. Now, of course, let's check it. Remember, we take our answer. We do opposite. We're going to add what we subtracted. We're going to add this 327. And then follow the same rules. 9 plus 7 is 16. Carry the 1. 7 plus 1 is 8. Plus 2 is 10. Carry the 1. 3, 6, 7. We get 706 is our answer. We solved it and checked it, and that's correct. Let's go to B. 450 divided by 25. You remember the first number always goes in the box first. All right, I'm going to divide this. 25 goes into 450 one time. 1 times 25 is 25. Bring down the 0. 25 goes into 200 8 times. 200. It is 0. So 450 divided by 25 is 18. Now, what's the opposite of division? Multiplication. So to check our work, we multiply. 25 times 18. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. Add a 0. 1 times 5 is 5. 1 times 2 is 2. We add these together, and I'm going to get 450. So after we divide it and got our answer, which is 18, I checked it by multiplying, and we did it correctly. All of these is just simple steps to find our answer. In just a second, we're going to be talking about different types of properties for addition and multiplication. It's different properties that can actually help us remember how to solve equations without actually writing things out completely. Let's go ahead and take a look at those properties. Here are the properties for addition and multiplication. Numbers 5, 8, and 9, we're not going to be discussing today. We'll learn those later on. But let's talk about each of these properties. The first one is commutative property of addition. This means no matter how you switch an addition problem, the answer is always going to be the same. Here is the example. 2 plus 3 equals 3 plus 2. No matter how the numbers switch, the answer will still be the same. 2 plus 3 is 5. 3 plus 2 is 5. That's commutative property. So the same rules also apply for multiplication. No matter how you switch the numbers, the answers will still be the same. 2 times 3 is 6. 3 times 2 is 6. All right, let's go to associative property of addition and associative property of multiplication. This rule says that your parentheses move, your answer still stays the same. Doesn't matter exactly where the parentheses are, the answer still stays the same. So we have this one here. 2 plus parentheses 3 plus 4 equals 2. And I see a mistake here in this chart. It should be, parentheses should be here. It should be parentheses 2 plus 3 plus 4. No matter how you solve this, the answer will still stay the same. Let's do the left side first. 3 plus 4 is 7, plus 2 is 9. Let's move to the other side. 2 plus 3 is 5, plus 4 is 7. No matter how you flip the parentheses, the answer will stay the same. All right, let's take a look at number 4, associative property of multiplication. Same rules apply. No matter where the parentheses are located, the answer will still stay the same. 3 times 4 is 12. 12 times 2 is 24. And 2 times 3 is 6. 6 times 4 is 24. No matter where those parentheses lie, the answer will stay the same. Number 5 we're going to skip. We'll come back to that one later on. Number 6, Identity property of addition. Identity property of addition says that if you add 0 to any number, the answer will be that number. So if I have 3 plus 0, it equals 3. Anything plus 0 will equal that number. 4 plus 0 equals 4. 5 plus 0 equals 5. 6 plus 0 equals 6. The identity property of multiplication follows the almost exact same rule. But of course, with multiplication, we use 1 instead of 0. 3 times 0 equals 3. You multiply any number by 1, and the answer will always be that number. Like I said, 3 times 1 is 3. 4 times 1 is 4. 5 times 1 is 5. And of course, the very last property is the property of 0. The property of 0 states that if you multiply any number by 0, the answer will be 0. 5 times 0 is 0. 6 times 0 is 0. A times 0 is 0. Let's take a look at an example to help explain this a little bit further. Example 3. Show 2 ways to simplify this expression. Justify each step. Because we're talking about 2 separate ways, I'm going to go ahead and show this example in 2 separate ways. Literally, which means I'm going to write this equation out twice. Alright, let's look at step 1. Step 1, of course, is just solving it like we normally would solve the equation. Parentheses first, we do 25 times 15, which is 375 times 4, which is 1,500. But we learn with the associative property that we can, no matter how you move your parentheses, you can still solve it the same exact way. The answers are still going to be the same exact. So in step 2, what we're going to do is we're going to change things around. Okay? What we're going to do, we're going to look at these parentheses first in the second step. We're going to take a look at these parentheses and these numbers. And we're going to see if there's a way we can actually solve this without actually doing the work for it. And of course, according to our rules, no matter how you turn numbers around in multiplication, the answer is still going to be the same. So it doesn't matter how we're going to do this with multiplication. We're just going to put numbers together that will work the best. So I want to move the 25 and the 4 together, because 25 times 4 is can get us a number that's really easy to solve. So to do that, I've got to move the parentheses. If I move the parentheses, I cannot put it in, I can't move it here, because if I move the parentheses alone, it's going to get me to 15 times 4. I have to move numbers first. What I'm going to do is I'm going to move the 15 and the 25 first. I'm going to do the commutative property first by moving these 2 numbers around. 15 times 25 times 4. Me moving these numbers around allows me now to do the parentheses. Let's change the parentheses over to where it's going to be around the 25 and the 4. So I did commutative property first by moving the numbers around, then the associative property by moving the parentheses around. And now we can solve this problem in our head. 25 times 4 is 100. 100 times 15 is 1,500. We follow the property rules to actually solve this equation where it's actually a little bit easier to solve. In example 4, we have simplify 100 minus 300. Reversing the order of the minute and the subtractant reverse the sign of the difference. We should automatically know that when we subtract 100 from 300, you're going to get 200. But because the minute and the subtractants are backwards, the answer is going to change from positive to negative. So we have 100 minus 300, which is 200. And because the bigger number second, that means it's going to be a negative 200. In this next example, we're going to be finding the value of x and y in these equations that show. We have a and b. Let's take a look. 6 plus x equals 30. The x in this equation is called a variable. It's a letter representing a number, and that number is unknown. But we can actually look at the equation and mentally think of what x actually is. X equals 24. How about b? 6y equals 30. Y is my variable. Y equals 5. Now the question is, how did you come up with these answers? How did you mentally think about how you got your answers of these variables? If you notice, you took 30 and you subtracted 6 to get the 24. And B, you took your 30 and you divided by 6 to get your 5. If you notice, that's opposite of what's actually showing in the equation. Because you have a positive 6, to get our answer, you subtracted it. It's a minus sign there. And the opposite of addition is subtraction. What about 6y? 6y is multiplying. What's the opposite of multiplication? Division. And that's how we got our answer. We're going to be using this later on to solve bigger equations. If you guys have any questions, make sure you schedule a time to come see me.